Your house is fed with 2 huts and 1 neutral, and only the imbalance goes back on the neutral. That does not mean current was canceled. Current is not being canceled in this process whatsoever, and there's been lots of talk on my page in the last day or two with neutrals and imbalances and what they do, and I'm hearing the term current is canceled way too often. Let me show you what it really does. This is what we're talking about here. We got about 11 amps on that hot, and we got about 7 amps on that hot, and if you did the math between the two, you end up with that. You have 4 amps on the neutral. All the amperage coming off the transformer has a path back to the transformer. None of it is canceled out. If it leaves the transformer, it goes back to the transformer. Let me show you the path it takes on my whiteboard. I don't know how I do this with the ring light, so it's going to be a little dark. But let's keep going. All right, I'm hating this horizontal thing, but TikTok's telling us to do it. But anyways, so here it is. This is the windings of the single-phase transformer. Here's one hot leg, and the center tap. So if this hot leg, if this is a 10 amp load and this is a 5 amp load, so this hot leg would have 5 amps on it, and this hot leg would have 10 amps on it, and then 5 amps goes back to the neutral. That's what you see with your meter. Now I'll draw the paths. All right, now this is the part that most people seem to have the trouble with, is we have AC. That means as a sine wave goes back and forth, on one point, the electricity flows in this direction. And this leg is, I don't know if you want to call it negative, positive, higher potential, low potential, supply, whatever. This is the higher potential feeding to this leg that is a lower potential. So the electricity flows in that direction. And then when the sine wave flips, everything reverses and the electricity flows in that direction. The two hot legs take turns being supply, return, being positive, negative, being high potential, low potential to each other. That is the first step you have to understand. So now let's follow the amps when the red path is being used. The 10 amps leave here. They come here. Now this has less potential than that leg. This is the neutral, but this has even less potential. But because the Ohm's law kicks in, when it gets here, this is only going to be a 5 amp load. The extra 5 amps that this leg brought up goes back on the neutral, and then the other 5 amps goes back that way. That's when the red is running. Now when blue is running, when we're following the blue path, this provides 5 amps, and the 5 amps gets here. This load requires 10 amps, and this is a higher, this neutral, even though we think of it as zero potential, this neutral has 120 volts more potential than this one. This is like negative 120 relative to the neutral. So when this 5 amps gets here, and Ohm's law calls for this needing 10 amps, this 5 amps, or in blue, this 5 amps never goes on the neutral and will continue to this load, and then the neutral provides an extra 5 amps that goes through and back to the transformer that way. So to summarize, when the alternating current is causing this end, the red end, to be the high potential, the neutral accepts the extra 5 amps. When the blue side is the high potential, the neutral provides the extra 5 amps. That's what happens when you have an imbalance, and that's why you'll see an imbalance on the neutral. Now what happens when it's balanced? Now when it's balanced, on red, we have 5 amps coming this way. Ohm's law calls for this one to be 5 amps as well. So these same 5 amps continues through and back to the transformer. When we're blue, this 5 amps goes that way. And the neutral is irrelevant. You could even remove it and everything would function just fine. Now what we get that's cool is these two loads are actually functioning in series. So even though it's a 240 volt circuit, because they're even, they divide the voltage evenly. And even though it's a 240 volt feed, you end up with the 120 that we're familiar with at both loads. Even without the neutral, you would get that 120 at both loads. All right. But if it is uneven, the neutral, by accepting the extra or providing the extra, the neutral allows us to maintain the balance of 120 and 120 because the loads are no longer in series on the full 240. The balanced section of them is in series on the full 240, but the imbalance goes back on the neutral. So I've explained this before in videos, and for some reason they don't get a lot of views when I show this diagram. People get all up in arms saying that I'm misunderstanding, I'm misrepresenting, I don't know what I'm talking about. I don't know. I showed that it works here with the DC battery stack. That's just how it is. If you get me somebody else to say I'm wrong, please provide the source. Don't just come up and say I'm wrong. It's how I was taught it, how I understand it, how I envision it. It fits with my visual analogy of how I know or think electricity works, and I've seen videos of people that I trust as more educated than me on the subject, engineers, explain it the same way. So, all right, people just have trouble, I think, what it is when they start hearing the neutral is providing current and not just accepting current. But it does. All right, thank you very much. So if you've watched my stove videos recently, how does this relate to stoves? So I'm sorry about my eyes. This horizontal thing, it gets you the views, but it's kind of annoying. I might go back to vertical. But of all the 40 amps or 30 amps or 50 amps available on the stove, the biggest the two legs ever get imbalanced is 1/3 of an amp on my stove. That was the biggest difference I could get on them. So I simply said, we're so close. If they could just engineer out that 1/3, then we wouldn't even need a neutral at all. And I didn't think that would be a big deal. And a bunch of people think it's a big deal. And some people think it isn't a big deal. But more importantly, I'm just hearing people say, oh, it cancels out, cancel it out, cancel it out. Yeah, that's not how it works. So, all right. Thank you very much.